In late October 2025, NASA's JPL telemetry recorded something no interstellar object should ever do. 3I/Atlas, a body already moving at tens of thousands of kilometers per hour, suddenly changed speed. Twice, instruments detected erratic accelerations and unexplained slowdowns, despite no visible outgassing or gravitational influence nearby. At first, scientists suspected faulty data. But when China's Purple Mountain Observatory confirmed identical readings, the anomaly became undeniable. Something was controlling or resisting its motion. As Atlas nears its closest pass to Earth, agencies worldwide are watching one signal in particular, because it just stopped matching any known natural object. When 3I/Atlas first appeared on the astronomical charts in 2024, few gave it much attention. To the untrained eye, it was just another interstellar drifter, a fragment cast adrift between the stars. But deep inside NASA's Jet Propulsion Laboratory, analysts noticed something different. Its light signature wasn't static. It shimmered, almost pulsed, like a heartbeat flickering through the void. For months, researchers monitored its trajectory. The initial calculations placed Atlas on a perfect hyperbolic escape path, destined to slingshot around the sun and vanish forever. Yet, as its orbit stabilized, anomalies began to emerge. High-resolution radar from Arecibo's successor network detected repeated deviations in velocity. They were too precise to be random. Something, or someone, was adjusting its course. NASA's early explanation was predictable: solar radiation pressure. The same weak push of sunlight that had once been used to explain Oumuamua's strange acceleration. But within weeks, that theory collapsed. The European Space Agency's near-infrared survey reported that Atlas's surface reflectivity was inconsistent with any natural rock. It wasn't ejecting gas, and its rotation was wrong. Instead of spinning freely, its axial drift kept locking into alignment with Earth's orbital plane, a behavior more like navigation than physics. Then came the flicker. Amateur astronomers across Australia began reporting rhythmic fluctuations in Atlas's brightness. Uniform pulses, repeating at intervals of exactly 46.8 seconds. When the data was cross-checked with telescope feeds from Chile, the results were identical. A cosmic object rotating randomly could never produce such precision. And yet, the pulse persisted, growing stronger as the object drew closer to the inner solar system. Behind closed doors, agencies argued. Was it tumbling debris reflecting sunlight, or an engineered beacon designed to be seen? NASA's Planetary Defense Coordination Office classified the signal as non-threatening but anomalous. The phrasing was deliberate, cautious. Still, internal memos revealed rising unease. One note from ESA's Mission Control in Darmstadt read simply, "Trajectory indicates reactive motion. Object appears aware of observation vectors." As weeks turned into months, Atlas's behavior shifted again. Its path began bending slightly toward Earth, not enough to cause alarm, but too much to ignore. Observatories in Spain, Hawaii, and South Africa logged identical readings, a gradual, consistent correction. And then, inexplicably, it stopped accelerating altogether, hovering in a state of kinetic equilibrium, as if waiting for something unseen. By mid-2025, the once dismissed interstellar object had become the most closely studied body in the sky. Every agency trained their instruments on it, searching for an explanation. But the more they looked, the stranger it became. The brightness pulses deepened, the rotation steadied, and radio silence held firm across all frequencies. Whatever Atlas was, rock, probe, or relic, it wasn't behaving like anything natural. And then, on August 17th, a new data thread emerged. A faint signal appeared on the Deep Space Network, not from Atlas itself, but from the space behind it. It was weak, deliberate, and encoded in a pattern eerily similar to its flickering light. Analysts ran spectral comparisons through every known cosmic source. No match. The object wasn't just moving. It was communicating. And as Earth rotated beneath its silent path, one chilling realization spread among astronomers. 3I/Atlas wasn't passing through. It was slowing down. It began as a ripple, a subtle spike on a telemetry graph that should have remained flat. At 2:13 Universal Time Coordinated, NASA's Goldstone radar complex caught the first anomaly. 3I/Atlas, the silent interstellar traveler, suddenly surged forward. Not by chance, not by drift, but with purpose. In a span of 9 seconds, it accelerated as if struck by an invisible pulse of energy. Then, as abruptly as it began, it stopped. The data was verified twice, then 3 times. Engineers assumed instrument interference, solar wind noise, or perhaps a software glitch. But then, halfway across the planet, China's Purple Mountain Observatory reported the same event, down to the millisecond. Hours later, Chile's ALMA array confirmed it too. 3 observatories, on 3 continents, had recorded an identical burst of motion. This wasn't coincidence. It was coordination. What made it worse was what didn't appear. No thermal plume, no particle trail, no reflected radiation from propulsion gases. Atlas had accelerated without expelling a single molecule of matter. In physics, that was impossible. Every action demanded a reaction, a counterforce. Yet the object seemed immune to the laws that govern motion itself. Within days, a joint session of the International Astronomical Union was convened. Scientists and defense officials shared encrypted telemetry files under a newly activated protocol, Project Hermes, a rarely used clause meant for deep space anomalies. The objective was clear: to determine whether the object posed a threat or represented an unknown form of technology. Supercomputers in Pasadena, Beijing, and Munich processed every conceivable explanation. Solar radiation pressure? Insufficient energy. Magnetic drag? The local interplanetary field was too weak. Gravitational resonance? No nearby body existed to pull it off course. Every simulation failed. Then, on October 14th, it happened again, this time in reverse. Atlas slowed down. No opposing force acted upon it, yet its velocity dropped by precisely 12.4 meters per second. The deceleration was perfectly smooth, controlled, and, most disturbingly, timed. When data from NASA's Deep Space Network overlapped with European tracking stations, analysts discovered a rhythm behind the fluctuations. Each acceleration and slowdown was separated by the same interval, 46.8 seconds. The same timing as its light pulses. It wasn't random motion. It was communication through movement. That revelation sent shockwaves through every scientific agency on Earth. Suddenly, the object's behavior wasn't just a curiosity, it was deliberate. Some speculated an autonomous probe using a propulsion system beyond known physics. Others whispered darker theories, a non-terrestrial artifact following a program written long before humanity could comprehend it. Amid mounting secrecy, a document leaked from within ESA's operations division. It contained only 3 lines of text. 3I/Atlas has demonstrated intentional velocity modulation. Suggest behavioral intelligence. Await confirmation. The document was quickly retracted, but the message was clear. Something unprecedented was unfolding. By late October, Atlas's erratic movement had drawn it onto a slightly altered trajectory, one that now passed within the Moon's orbital distance. Teams worldwide scrambled to recalibrate tracking systems, each hoping for a clearer answer. But as the data poured in, another layer of the mystery emerged. Embedded within the telemetry signals were subtle fluctuations, like background noise with a pattern too structured to ignore. It was as if Atlas was sending data back, but not to Earth. And then, a new reading appeared from NASA's Jet Propulsion Network. The acceleration patterns weren't random numbers. They were coordinates. But where they led, no one could yet explain. As 3I/Atlas crossed the invisible threshold of the Moon's orbital boundary, every radio dish on Earth turned to listen. Its erratic speed changes had already shattered the rules of celestial mechanics. But what happened next would rewrite them entirely. At 1822 Universal Time Coordinated, a faint tone appeared on the Deep Space Network's spectrum analyzer. A signal, rhythmic, repeating, and eerily familiar. It matched the timing of Atlas's 46.8-second light pulses exactly. Analysts initially dismissed it as an echo, perhaps interference from the Moon's reflective surface. But the waveform was too deliberate, too organized. It didn't scatter like noise, it sang. Then, at 18 hours 23 minutes and 41 seconds, Atlas vanished. Radar lock broke without warning. The object's signal dropped to 0 as it slipped behind the lunar limb. a moment of total silence that lasted 47 seconds. When it re-emerged on the far side, its velocity had changed again. The object had slowed down as though something in the moon's shadow had exerted force or contact. China's Keiqiao-2 relay satellite, stationed beyond the moon, detected a secondary burst from the same coordinates. The transmission was unlike anything seen before, narrowband, phase-locked, and perfectly symmetrical. It contained no spoken language, no cosmic static. Instead, it was structured noise, a pattern repeating at harmonic intervals. Too complex to be random, too precise to be natural. Across global control rooms, analysts began comparing notes. The waveform's symmetry resembled encryption, not in binary, but in geometry. Peaks and troughs mirrored like folded paper, creating what one JPL technician described as a mathematical palindrome. It was as if the signal carried instructions, but in a language no human system could translate. For hours, data centers on 3 continents ran spectral deconstructions, fractal mappings, and Fourier analyses. Every model returned the same result: non-terrestrial pattern consistency. In simpler terms, it was designed. But designed for what? That question fractured the international response. NASA proposed the signal could be a natural resonance, perhaps the result of Atlas's electromagnetic field brushing the moon's crust. The European Space Agency rejected that instantly, pointing out the near-perfect timing synchronization across multiple receivers. Meanwhile, China's Purple Mountain team went further. They released a classified briefing suggesting the burst might not have originated from Atlas at all, but to it. If true, that meant something behind the moon had transmitted a message, and Atlas had answered. By dawn, a pattern began to emerge. The intervals between transmissions matched the distance between Atlas's accelerations recorded earlier that month. The pulses, the motion, the radio bursts, they were all part of one continuous system. A language built not from words, but from physics itself. Publicly, agencies remained silent. The official statement referred to minor radio fluctuations consistent with deep space interference. Yet within NASA's internal communications, one phrase began circulating quietly: lunar interaction event. Whatever had happened behind the moon wasn't random. Something had synchronized with 3I/Atlas, an exchange invisible to the human eye, but clear in the data. And as scientists replayed the raw telemetry again and again, one final discovery sent a chill through every listening post on Earth. The signal's final burst had originated not from the moon's surface, but from 19 kilometers above it, an altitude where nothing human should be. For weeks, the global scientific community had stared at streams of numbers without context. Every spike, every pause, every microscopic deviation in 3I/Atlas's motion had seemed random. But deep inside a data lab at the Harvard-Smithsonian Center for Astrophysics, a physicist named Dr. Elena Varga noticed something no one else had: a rhythm hidden in the chaos. When plotted on a time sequence graph, Atlas's accelerations weren't evenly spaced. They were separated by intervals that corresponded exactly to prime numbers: 2, 3, 5, 7, 11, 13, and so on. It was the same mathematical sequence used by SETI researchers decades earlier as a theoretical marker for intelligent communication, a code nature would never produce by chance. The revelation tore through encrypted scientific channels overnight. Every observatory rushed to re-examine its data. Within 24 hours, the same pattern appeared in readings from Goldstone, ALMA, and China's radio arrays. The odds of this occurring naturally were statistically impossible, less than 1 in 10 billion. Atlas wasn't just changing speed. It was broadcasting information through motion. When the acceleration values were converted into spatial coordinates, another layer unfolded. Each burst pointed toward a specific position in the night sky, a sequence of waypoints forming a narrow corridor between the constellations Draco and Ursa Minor. It was an empty region of space, devoid of any cataloged stars or exoplanets. But radio astronomers knew the area for another reason. It was the source of a series of unexplained microwave echoes first detected in 2023, signals that had no origin and no apparent purpose. As decoding teams synchronized their analyses, they discovered that the velocity bursts mirrored those same microwave frequencies. The alignment was too perfect to ignore. Whatever was driving Atlas, it was tracing a map, one that led back to the void. At NASA's Jet Propulsion Laboratory, technicians projected the path on a 3D model of the solar system. Every acceleration burst, every moment of deceleration, aligned precisely with one geometric arc, a curve that intersected directly with Earth's orbit on a single date, November 4th, 2025. The discovery was quietly classified under Signal Propagation Event. Official channels were sealed. Publicly, NASA maintained that Atlas's erratic behavior was due to thermal variation across its irregular surface. But behind closed doors, international decoding teams were ordered to focus on the numbers, not the trajectory. The reason was chilling. The prime number sequence wasn't just repeating. It was counting down. Each new velocity pulse shortened the interval between bursts, as if marking time toward a fixed endpoint. The calculations placed the final convergence within hours of Atlas's closest approach to Earth. In a secure meeting at the European Space Operations Center, Dr. Varga presented her conclusion with quiet disbelief. This object is following a navigational program. Its motion is the message. The room fell silent. Around the world, researchers began to realize that 3I/Atlas wasn't simply passing through. Its course, its code, and its countdown all pointed toward one inevitable intersection, the planet itself. And as the object's signal intensified, one truth became undeniable. The numbers weren't just data. The numbers were a map. By the dawn of November 3rd, 2025, every global observatory was awake. From California's Palomar Peaks to the frozen plains of Antarctica, telescopes locked onto a single target in the night sky, 3I/Atlas. The object that had crossed light years of interstellar space now drifted silently toward Earth's orbital path, its strange pulsations growing more rapid, more deliberate. Every signal, every change in speed, had begun converging toward a single point in time. 23:47 Universal Time Coordinated, November 4th. Inside NASA's Jet Propulsion Laboratory, a long-range transmission board flickered with live telemetry. Engineers noticed a haunting symmetry in the data. Each acceleration interval now mirrored its deceleration pattern exactly. Atlas wasn't just moving, it was aligning. Its trajectory, velocity, and energy readings had synchronized into a mathematical harmony, as if preparing for something final. The European Space Agency activated full-spectrum monitoring, while China's Purple Mountain Observatory switched to continuous tracking mode. Across the world, military and civilian satellites redirected their antennas, recording an invisible rhythm pulsing through the electromagnetic spectrum. To the naked eye, Atlas was just a dim, distant light. But to the instruments listening, it had become a beacon. Then came the anomaly in Antarctica. At the Ice Cube Neutrino Observatory, a vast network buried deep beneath the polar ice, sensors began registering faint oscillations. The data didn't match any known cosmic particle pattern. Instead, it pulsed at the exact frequency of Atlas's brightness cycle, 46.8 seconds. As the object moved closer, the readings intensified, as if something buried under the ice was responding. Dr. Marianne Clark, lead physicist on site, reviewed the data with disbelief. The oscillations weren't random. They formed standing waves, interference patterns, like two signals resonating across impossible distance. One from the sky, one from beneath the Antarctic surface. That same hour, NASA confirmed the final acceleration event. Atlas slowed to a near-constant velocity, the same speed it had displayed before the lunar signal. It was as if it had reached the final waypoint in a long, deliberate journey. And then, at 23:47 Universal Time Coordinated, the signal hit. Every radio telescope on Earth, from the Deep Space Network to the ALMA array, went momentarily blind as a blinding surge of energy saturated the spectrum. The transmission wasn't noise. It was structured, an identical sequence repeated 3 times, across every frequency known to science. Then, silence. Power grids in several observatories momentarily flickered. Data storage units crashed from electromagnetic overload. When systems rebooted, the signal was gone. No residual radiation. No measurable echo. Nothing. In the aftermath, analysts scrambled to decode what little data survived. The sequence wasn't random. It resembled a triad pattern. 3 pulses separated by prime intervals. 235, a signature that matched the earliest acceleration codes of Atlas itself. To some, it was a final transmission. To others, a handshake. But one detail haunted every team reviewing the data: the transmission's time delay. The echo detected by IceCube arrived exactly 2 seconds before the main signal hit Earth satellites, meaning the resonance had begun here first. By midnight, Atlas slipped past the outer atmosphere, its trajectory now stable and silent. The countdown had ended. The signal had stopped. But somewhere under the frozen Antarctic plateau, sensors continued to pulse, faintly, rhythmically, in perfect synchronization with a light that was no longer there. The event window had opened. What it opened to remains unknown.